we come up here, Control N. You're going to have to help me. Icon, let's say 1K, P plus, oops, I don't like that. What's that? I don't want to find out. Those sometimes it will and sometimes it won't. So what's the first thing I'm going to put down? What is that? I can put down N well. Why don't we do the resistor part first? What can I put down first? Well, I can put an active layer down, but I need to make a connection, right? So why don't I put down P active? How's that? So let me see. P active, does that make sense? So now, what's the only thing I can connect to this node? Metal. So if I go over here, P active, let's expand it a little, and I'll just be sloppy since I want to do it fast. Now if I do this and I drag it over, I connect to metal. That's wrong. How do I make my P plus connection in the middle there? No. Well, you can't. If you do this, you can't. The only thing you can get in this is the contact to make a connection. So how about we go put, remember we're doing a resistor. In digital it's just switches and gates and stuff, right? This is an analog thing, measuring sheet resistance. We're making a resistor. So I'm going to go down here and put P active well node. Let me see. P active.
Very bottom left.
This one? This one? Let's try it. Whoops. Ah, looking good. So it made the connection, right? So let's see if I can DRC without it. Whoops. Okay, no errors. Now, how do I estimate the sheet resistance? Measure of the active area size between the 2 points and the number of squares. And then we know over here that my P plus is 107 ohms per square. Okay, if I go make this, I can export these two nodes, but it won't work because I'm sitting in a substrate, so I need to put down my N well, whatever size, just pick something, 120 by 30. You can estimate the right size, fit. And then what's the last thing I need to do? And somebody asks you, why do you need the N well? The answer is to isolate the P plus that I'm using for a resistor from the substrate. So then I come in and put the N well connection here. Let's look at a 3D view. So I've got my active P plus resistor sitting in the N well. I've got my connection to the N well. I can tie this to VDD. Why wouldn't I want to tie this node to ground? Yeah, so I don't forward bias the P plus N well diode. That's a question I would ask. Suppose you decided what's the best position, what's the best potential to tie this to, and the answer is 5 volts for several reasons. One, you don't forward bias the P plus N well diode. 2, you're always trying to get the maximum reverse bias across the resistor so you get the least variation in the sheet or in the resistance of the resistor, because you got the widest depletion region. Yeah, it's N well to substrate's widest, but it's also between here and the N well over here, right? Because it doesn't matter if these are at 5 volts, then.
Well, I was thinking
Oh yeah, but there's also the 5 volts between here and the substrate. Here, and you could also come around here and make a. You could say, oh, I'm gonna go. Oops, make a. Oops, I can't see what's what. You could go put a ring around the resistor just to ensure the N well's tied down really well. Okay, there's a lot of concepts here. Is everybody following? Why we would lay out, good test question. Sketch the layout of a 500 ohm P plus resistor assuming the sheet resistance of P plus is 100 ohms per square. If you don't put the contact, the end well in, the contact to the end well, and show 5 squares, you haven't done the problem right. Any questions? Instructor provided adequate opportunity for me to ask questions in the class. Okay.